It is the small signal equivalent. Okay, just for your benefit, let us bring back the circuit in picture. Let us draw the large signal diagram for this one. So let's draw the small signal equivalent. We will first remove the conditions that we have and then proceed. So how do we do that? First thing we will start with this. This is the RD. We have the CMOS NMOS device with its bias circuit VB, voltage V out, RD. When you have VDD present here, you take this value. There is the R out of this device, the saturation region. Then we have the RS, which is going to come in the source terminal. Finally, the VN supply. Now let us draw small signal equivalent. Small signal equivalent, let us bring back our gray box. Right. So you will have three terminals. Gate, drain, source. So now let's start filling up. Gate, you have VN. So this is plus minus. So at the gate you have VN. Then, sorry, at the source you have VN. My apologies. This is your RS. And at RS you have next you consider is what is your V1. V1 is VB minus VN. Okay. Then comes your GM VGS. So this is GM1 V1. This is a VGS supply. Then you have R0. Correct. After R0, now in this case the GMB is not connected to ground. So in this case you'll have GMB factor also. GMB. Now this, what is the voltage supply here? Bulk to source. So VSB. Finally you have the RD resistance connected to the load. This is your V out. So this is current ID. This is IL, and you know IL is minus ID. If you apply KCL here. Right now, what are the things that you have to apply? So what is the supply voltage applied at the gate here? VB. Remember, so this is the other connection that you have. Now find out what are all the values. How do you figure out? First thing is find the input voltage, find the loop here. Apply KVL at the input loop. So KVL at input loop. KVL at the input side. So what do you get here? V1. V1 plus the drop across this VS plus VN. These are the three terminals, but each one is taken in the negative sense. So you will start off with V1, then go negative, minus voltage drop across this. So what is the voltage drop? This value, right? V out by RD. This is a current, right? So we'll do it this way. V1 plus ISRS plus Vin equal to 0. Now this IS that we get here flowing to here is the same current ID. ID is IL. IL is V out by RD. So if you substitute, you get minus V out by RD times RS plus V in V1 is equal to 0. This first equation. Second, let us have one more loop on the output side. So, KVL at output loop. The KVL output loop, you will again can start from whichever side you want to start. So if you start from here, our output, the voltage drop here across output is equal to the voltage drop across this resistor plus the voltage drop across this resistor plus the voltage drop from the supply voltage, right? So we can just write that. So V out is equal to I R out plus ISRS plus V in. So let us now write I. This I can be written as negative of these two terminals. You'll have to apply KCL here. So that will be minus V out over RD, then minus GMVN, G1 V1 minus GMV V1. I is taken care of, then same value, minus V out by RD times RS plus V in. So you have V out value, you have V1 value which you will substitute, then separate out the values, and finally you will get the expression V out by V in is equal to voltage gain is equal to GM plus GMB R0 plus 1 whole divided by R0 plus GM plus GMB R0 RS plus RS plus RD whole multiplied by RD. Right? So what do you infer from this circuit again? You infer that it is a non-inverting gain. Non-inverting gain, it has a gain larger than CS stage. Okay, in this case, it is due to body effect. Right? Here, body effect is a desirable feature. Now, in this particular case, we have assumed that the RD is passive. Right? Now, what happens if RD is replaced with an active source? So, RD passive. RD is related by ID, which is a current source. Or you can use ID as a diode connected supply, active source. In that case, what will happen? In that case, your RD becomes a constant current source. Then the effective total resistance will change and become only the numerator, GM plus GMB R0 plus 1. Because RD will become infinity for ideal source. So the moment this infinity factor comes in, this makes no sense in that case, right?